All right, people, I'm going to talk to you about the mole. What is the mole, you might ask? The mole is a number. The mole is a number. The mole is a number. And this is that number, 6.02 times 10 to the 23rd. It's a really big number. Now, you've heard of using words for numbers before, like how about this word right here, dozen? That means 12, right? Well, when we say the word mole, it means this number. It's the same thing, okay? It's the same thing. The word dozen means 12. The word mole means 6.02 times 10 to the 23rd. Let's talk about how big that number is. This is it. That's the number. Now, what is that number, Mr. Perkins? There are this many atoms of hydrogen in 1 gram. What? Yes. This is how many atoms of hydrogen it takes to weigh 1 gram. That's how small atoms are. This is roughly equivalent to all the sand on all the beaches and all the deserts in the world, all the grains of sand. Isn't that crazy? This number is 6.02 times 10 to the 23rd. But what's great is it's just like we're using the word dozen. We use the word mole, it means this number. We use the word dozen, it means 12, okay? So this is how many atoms, 1 mole of atoms of hydrogen weigh 1 gram. How do we get this 1 gram number? Here's where we get it. The number 1 comes from the periodic table. Look at hydrogen, and I don't know how well you can see that, but if you look, the atomic mass for hydrogen is 1.008, okay? Now, what that means is if you have 6.02 times 10 to the 23rd atoms of hydrogen, they will weigh 1.008 grams. That's crazy, right? Now, we can use this with the periodic table to find weights of all the compounds. What do I mean? Here's a picture of sodium chloride, okay? Sodium chloride is table salt. It's a sodium positive atom stuck to a chlorine negative ion. These two ions are stuck together. Now, if you had a whole bunch of these, if you had 6.02 times 10 to the 23rd of these compounds, they would weigh 58 grams. Mr. Perkins, where are you getting this from? Well, I look on the periodic table here for sodium, and you'll see that the weight for sodium is 22.99. So I'm going to say the sodium is 23 grams. And then we go over here, and here is chlorine. The weight for an atom of chlorine is 35.45. So I'm just going to call that 35 grams. 23 grams plus 35 grams is 58 grams. If you had 6.02 times 10 to the 23rd sodium chloride compounds, they would weigh 58 grams. We know this. Let's talk about how much other molecules would weigh. What if we had carbon dioxide? Let's say we froze, just for the fun of it, we froze some carbon dioxide and we had some dry ice, okay? Now, if we had 6.02 times 10 to the 23rd carbon dioxide molecules, we know how much they would weigh. here is carbon. On every molecule of carbon dioxide, there is 1 atom of carbon. Its weight from the table is 12, okay? So this many atoms of carbons would weigh 12 grams. And notice there's 2 oxygen atoms, right? Is it CO2? Each oxygen, we look up its number, is 16. So we have 16 grams and another 16 grams. So 12 plus 16 plus 16 is 44 grams. If you had 6.02 times 10 to the 23rd molecules of carbon dioxide, you would have what's called 1 mole of carbon dioxide. And 1 mole of carbon dioxide weighs 44 grams. So 1 mole, instead of saying 1 dozen, we say 1 mole. 1 mole of carbon dioxide, if you have this many molecules of it, that's a mole, it would equal 44 grams of weight. Now, what we can do later is learn to count by weighing. But right now, we're just going to talk about what does this mean. Let's do one more. What if we had O2, O2 gas? If we had 6.02 times 10 to the 23rd of these molecules, O2 would be a linear molecule like this, right? Right? There's O2. If we had 6.02 times 10 to the 23rd of these, it would weigh 32 grams. Mr. Perkins, where'd you get that? Well, this oxygen, 16 grams. If you had this many of these, it weighs 16 grams, but you also have another one to match it every time. What's 16 plus 16? 32 grams. You literally just add up oxygen from the table. Why don't you try one yourself here? How much would 1 mole of propane weigh? Why don't you tell me? Work on it, all right? Every carbon weighs 12 grams. And you've got 3 carbons on every one of these molecules. And then you have 8 hydrogens. I should be writing a 1 here every time. 1, 2, 3, 4, 5, 6, 7, 8. Every hydrogen atom weighs 1 gram per mole. So if you had 1 mole of this, you would have 44 grams would be equal to this many molecules of propane. Or in other words, 1 mole of propane is 44 grams in mass because you have 6.02 times 10 to the 23rd of these molecules. Does that make sense? I hope it does. There's a real simple worksheet, and tomorrow we'll move forward.